Okay, so hello everyone. The question which we will be solving today is today's LeetCode POTD, which is count the number of complete components. Okay, as you can see, the question number is 2685 and it is marked as a variable, right? Okay, so like the question is very good. Okay, so there are many concepts involved in it. Okay, so the video might be long, but it will be like beneficial. Okay, so let's just read the description and try to solve it. Okay, you are given an integer and there is an undirected graph with n vertices, number from 0 to n minus 1. You are given an 2D integer array edges where edges AFI denotes that there exists an undirected edge connecting vertices A and B. Suppose it's something like this, and this is given, so there is an undirected edge between them. Okay. Connected component is a subgraph of a graph in which there exists a path between any two vertices, uh, and no vertex of the subgraph shares an edge with the vertex outside the subgraph. Okay, we will be coming to it. A connected component is said to be complete if there exists an edge between every pair of its vertices. Okay, so like see in this question, like in this subgraph, there is an edge between 0 1. There is an edge between 0 2, 1 2, and there is an edge between 0 2. Plus there is an edge between 2 0, 2 1, and 1 0. See here there exists an edge between every vertices. There is an edge between 0 to 1 and 0 to 2. Similarly for 1 there is an edge between 0 to 1, 1 to 0, and 1 to 2. And for 2 there is an edge between 2 to 0 and 2 to 1. Right, so it's a complete uh, component. Okay, so before moving forward, I would like to discuss something. Okay, so tell me one thing, that how can we find that a component is complete? Okay, suppose there is this component, right? So how many edges are there? Zero. Okay, for the if there are one vertices, there are zero component, zero edges, right? Okay. Suppose now, let me just write it. Suppose there are two vertices. So how many edges there? Okay. Suppose there are three vertices. So how many edges should be there? Three. Okay. See, how many edges? Like there is one, two, and three. Right. Okay. Let's move forward. Right. Okay. Suppose there are four vertices. So how many edges will be there? Six. Let me just count it for you. One, two, three, four, 5, and 6. Right? There are 6 edges. Okay. Suppose, okay, there are 5 edges. Say 5 vertex. How many edges will be there? Let me just count. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? Okay. So if a component has like this number of edges, like 1 2 3 4 5, so the number of edges should be like 0, 1, 3, 6, 10, right? Okay, so but they've like just a second. Okay, but they've like how can we find it? Okay, let's just do some observation, right? Okay, so for like 1 there will be 0 edge, right? For 2 there will be, we can write 1, 0 plus 1. Okay, we have seen it. Okay, we are just, I'm just like writing the same thing. For 3 there are 1 plus 2, which is 3. Okay, for 4 there are 6, right? So can we write like 1 plus 2 plus 3, it's 6. Okay, for 5 there we can write something like 1 plus 2 plus 3 plus 4, which is 10, right? So like suppose there are, see, what is this? Does it remind you like how can we calculate it? It is sum of n natural numbers. We can write something like this: n into n plus 1 by 2, right? But for 5 we are going till 4. So what it will be? N equal to n minus 1. For this we can calculate, right? See, if vertex is equal to 0 or vertex is equal to 1, okay, we will have 0 edges, right? Else vertex minus 1 into, this should be plus, this should be plus, then this will be minus, so this will eventually cancel out, and this will be like, it doesn't matter. Okay, so it will be like vertex at which we are standing into vertex by 2. So this will be our formula. Okay, so now we know that if we have like some number of edges, we can find out how many, like if we have some number of vertex in a component. Okay, let me just write it. Okay, now we know that if there are v number of vertex in a component, then how many number of edges, just a second, edges are required, right? How many? V minus 1 into V by 2, right? Okay, so like okay, so now we know it. So now coming back to the question, we are talking here about components, and it's clearly mentioned that it's graph. Okay, it's graph. Okay, and then we have components, right? Components. Okay, tell me one thing, does this remind you of something? Does it remind something, reminding something to us? Like I guess day before yesterday POTD, or like in just 2 to 3 days, there was, we discussed something. What was it? if graph and component, uh, what do we use? Yeah, right. If you might have guessed it, it's DSU, right? So same thing we are going to use here, right? So we know that okay, so we can now find easily the components. We know how many components are required to make the component complete. Okay, so yeah, let's we just do it right, then things will be more clear. Okay, so let's just take this example, right? Because it will be covering the this case also, okay, in which it's not correct. I should let me just do it like so. I'm doing it when important. So just a second. Okay. Yeah, we are now good to go. Okay. Okay. Yeah. So this is a parent one, like in the DSU you might be doing. Okay, this is the parent and initiate will have 1, 2, 3, 4 because each one is the parent of the cells, right? These are the queries, right? Okay. The first query comes 0, 1, 0, 1. Okay. So what can we do? We can just make this the parent of. Okay, let me just also like make the graph for you, right? Okay, it will. So 0 was separate, 1 was separate, we connected an H. This count represent the number of edges, right? So now one's parent is 0, right? Okay. So how many edges are there? Like one. Okay. Then comes 0, 2. Okay. 0, 2. This is separate, right? This is separate. Okay. If we connect it, it's two parent, it's two parent, 0, right? And there are how many edges now? 2, right? Edges connected to 0. Okay. Then we have 1, 2. This is the third query. 1, 2, 1, 2. Okay. See, 1, 2 are already connected, like in the are of the same component, but the number of edges will increase, right? For this component, parent will represent. Okay, I forgot to mention. Parent will, I mean the parent edge count will represent the total number of edges. Okay, so we are working on this principle. Okay, so it will become 3, right? Let me just remove it from here. Okay, so now the edge count will become 3, right? 2 comma 1 we connected this. Okay, so there are how many edges? 3. 1, 2, 3, and the parent is 0, right? And it's representing the number of edges, right? So now 3 comma 4 comes. 3 comma 4. Okay. 3 comma 4. These two are of different components, so we connect them. The parent of 4 will become 3. and the 3 counts will increase by 1, right? Okay, it was the fourth query. Okay, then comes 3 comma 5, right? 5 is belongs to different component 2, so we connect it, and the number of edges become 2, right? So how many number of edges are there? 1 and 2, right? Okay, so by looking at the parent, we can find out how many number of unique components are there, like how many number of components are there. There are 2 because there is only 0 and 3 in the component in the parent array, right? And this is representing the number of edges. Okay, so in a map we can store something like this. Okay, the count of 0 is 3, the count of, okay, in a map we will be having something like, in a map, okay, in a map we can store how many, it's like the number of parents and the number of vertices in it, right? For 0 there are 3 vertices, 0 1 2, right? And for 3 there are 0 3 4 5. Okay, so map of, let me use that for it. In a map of 0 we have 3 components which include 0 and 2, right? In a map of 3 we have 3 vertices, like vertex 3 comma 4 comma 5, right? Vertex, these all are the vertex, right? Okay, so okay, and we have a count, right? And plus we have count. Okay, let the count have 0 represent 3, and the count of 3 represents the 3 has the value 0. Okay, so this is the part, like word number, this is the number of vertex, right? This is the number of edges. Okay. We have number of vertex in a component, right? Plus we also have number of edges in a component. Okay, so by the, like, we have the number of vertex in a component. Can we find out how many number of edges are actually required, and then compare it to the number of edges in a component? And if it's the same, yeah, then we can say that it's a complete component, right? Okay, we can find out the actual edges required, actual edges required, and just compare it with this one. If same, then answer plus plus, right? See, okay, let me just like do that complete thing for it, right? We have 3 vertices, right? So 3 minus 1 into 2 by 2 comes 3. Is this 3 and this 3 same? Right? So we do the answer as plus. Answer will initially be 0, so it becomes 1. So it becomes like just a second. So it becomes 1, right? Okay. Then we again have 3. So 3 minus 1 into 2 by 2. Okay, I something right. Okay, okay, okay. I'm so just a, this will be 3. Okay, okay. I just made a mistake. Okay. This will be 3, right? This will be 3, this will be 2. So this becomes 2 and this 2 cancels. So this becomes 3. So this 3 and this 3 are it like the number of required. This is the required. Okay, actually required. And this is what we have. So it's same. So answer will initially be 0 and we do the answer plus plus. So it becomes 1, right? Okay. Then we check for MP of 3. We have 3. 3 minus 1 into 3 by 2. This also cancels. This gives us 3. This is the required one. And this is what we have. We have 2. So it's not equal. So we like don't increase the value of answer. So what answer do we have? We have 1. So let's just check it. Okay. We have 1. Right. Okay, so that's for this cases. They're like okay, so there are more edge cases to cover in this question. Okay, so now this is the basic question, like the basic understanding. Okay, now we are moving to the more edge cases, right? Okay. See, suppose in this question, like this edge case, right? Okay, I won't be taking much time in it, but I am like trying to give you the intuition that why I have done things in this question. See, we have 1, 2. Okay, this is the counter. Okay, okay. So this is a counter. We connected 1, 2. This is 2. So we increases its count, right? Okay, it becomes 1. Okay. This then comes 3 comma 4. So 3 comma 4 connected and we make the parent as 3. So the 3's count increases. Then comes 1 comma 4. Then we connect 1 comma 4 and we can see that like okay yeah. So we can see 3 comma 4 aren't connected, right? So we make the parent 4 and we just connect it, right? We connect, right? And we increase the count of 1 by the count of 1 by 1, right? So it becomes 2. But wait, are there 2 edges in it? No, no. Okay, let me also just write the parent. Okay, here comes the parent, right? Parent 0, 1, 2, 3, and then 4. The parent of 0 is 0, parent of, okay, okay, parent of 1 is 1, parent of 2 is also 1, parent of 3 is currently 3. This was also 3 now, but it has become 1, right? Okay. Okay. So, like, no, there are 3 edges. Okay. So, while merging, if they don't belong, they don't belong to the same component, we do add the count of PV. Okay, see, this is the PV here, right? And this is the PU, right? So if we are merging the like two different components, okay, then we can just add this like see, the PU is here one and this is also one. Okay, we are adding this edge, so plus one for this, plus this is also having an edge. Okay, so plus count of PV for this, count of PV, and this is what? This is count of PU. Okay, so while merging the different component, we add the PV also. Okay, if you are merging in the same component, like suppose if you like add 5, so we can just add count of PU plus 1. Okay, so yeah, then like okay, so then here's another edge case, like see, okay, in this also this like this question is good. Okay, this teaches you many things, so there is like not a need for panicking. The video might be long, but this question covers many things, right? If we find the parent of it, like if we go the step by step, we will have something like 1 2 2. So according to our algo, this in this question we have two different components, right? Because there is one and there is two, but ultimately if we see, we have a single component because see, zero's parent is 1 and 2's parent is 2 and 2 is the ultimate parent. So we are like doing the compression here. Okay, compression is required, compression is required. Okay, so we will be doing the compression and then all the edge cases will be covered. Okay, so yeah, that was all the edge cases. First we understand how the basic things work, basic, then we have merging two components, merging two different components, right? And then we have seen the compression here, right? Compression here, right? Now let me just go through the code and the things will be much more clearer to you. Okay, okay, so we are starting with the DSU. Okay, this is the DSU. Okay, we have a parent and we have a count, and we also have a rank. If you want, you can use a rank. If you want, you can use rank, but without rank also, but without rank it will run without rank also. So we're initializing the parent, the count, the rank. Okay, so this is the basic one. This is the find parent function. So this like we are finding the ultimate parents, right? See, if they belong to same component, we're just adding it, doing the plus one, right? Okay. In this part, they belong to different component. Okay. So what we are doing the count parent of u plus parent of v plus one, right? Okay. We have discussed this. Okay. Similarly, in this case also, we are doing the count of pu plus pv plus p1, right? And storing it to pu In this, on the basis of rank, PV's rank is more, so we are storing it in the P, right? The rest is it's all the same. Okay, okay. So this is the DSU code, right? Okay. Now let's come to the solution functionality. Inserting into DSU, right? Now this is the compression part. Compression. Okay. We are just ensuring that each each element has this ultimate parent, have its ultimate parent. Okay, each let me use a different color for it. Each vertex has ultimate parent of it. Okay, ultimate parent, right? Okay. And then we have used the map. Map for what? Map for storing the count the edges plus unique components, right? Okay. And then we are doing this is our count of answer. Where is it? We will be returning it as that. So we are just iterating to it, like for what edge, how many number of edges are there. If edges is greater than one, then we are calculating the actual edges, comparing. If it's true, we are doing the count plus plus, and we are returning the count at the end, right? This is the code. Okay. As you can see, there are many test cases in it, right? Okay, it's like 3 cases. See, the code is running fine, okay, but you shouldn't be like disheartening from this question. Okay, this question might uh, seems to be like less intuitive or something, but you should be trying out and doing the trial and for your like by yourself. Okay, the question and the code link will be in the description box. Okay, where you can go and check it, and yeah, you should be solving this question. Okay, so yeah, that's all for this question, and have a nice day ahead, right?